The left one's tapping, the right one's not.
Ladies and gentlemen, welcome to the Satellite 2022 Wednesday morning keynote. Bandwidth as a Service, a new revolution in AI-powered satellite connectivity. Please take your seats, the program is about to begin. Ladies and gentlemen, please welcome your Satellite 2022 Conference Chair, Jeffrey Hill.
Good morning, everyone, and welcome to day 3 of Satellite 2022. Once again, my name is Jeffrey Hill, Chair of the Satellite Show. Thank you all so much for joining us. I hope you've enjoyed your experience so far and are ready for yet another exciting and action-packed day here at Satellite. I saw the exhibit hall yesterday and things looked very, very busy down there, so I'm very happy to see that, and I hope you are enjoying your stay with us here. This morning's opening general session is presented by our friends at Datasat, one of Saudi Arabia's leading infrastructure and digital service providers. Datasat is on the verge of securing a patent for a breakthrough IoT technology that could change the way satellite companies serve their end users. This morning's discussion will include case study presentations, Q&A, and a demonstration. But first, we will start with opening remarks from Datasat President and CEO Felix Thomas Wass. Before being appointed CEO of Datasat in 2017, Wass's career included posts at multiple mobile network operators, including Siemens, and he is here to give us an overview of a new disruptive bandwidth as a service evolution that involves a combination of AI, machine learning, cloud networking, ground systems, and satellite bandwidth. Please welcome Felix Thomas Wass.
Hi, good morning, everybody. I'm happy to see you around and that we could tempt you away from the coffee and from the breakfast which was laid out. Great to see so many of you in person rather than online like we got used to over the last 2 or 3 years. And it's really great to be here at this show. Well, starting with the presentation, not many of you may have heard of Datasat. Datasat is not a young company. We have been around in Saudi Arabia for 40 years. We are a joint venture between Deutsche Telekom Consult and a Saudi investor with a history since 1982, coming from the infrastructure business, building fiber optic networks across the Kingdom of Saudi Arabia, managing fiber networks, managing hospitals, 109 hospitals for the Ministry of Health, and managing a couple of data centers for Saudi Electric. So our core business used to be infrastructure business, and this was a very steep learning curve for Datasat, preparing us for great things to come, like what we are presenting today. Around 2004, we started entering the VSAT business. We are providing VSAT services. We have about 400 megahertz satellite capacity under management for various customers, from governmental customers, finance sector. We have 2,000 ATMs under management. Obviously in Saudi Arabia under the oil and gas sector, from offshore rigs to desert exploration camps, also in the maritime sector. More recently, starting 2010, we started with digital services, data center hosting, and cloud services. And that's really important because it drove us to understand specific requirements of high security clients. If you are talking about high security, just to give you a feeling of whom we are hosting, if anybody of you was traveling to Saudi Arabia in the last couple of years, the visa was issued via Datasat Cloud. STC, Saudi Telecom Digital Bank, is hosted on the cloud of Datasat. We have the Central Bank of Saudi Arabia is hosting all the payment gateways in our environment. Also, we started offering IoT services for different verticals, the mining vertical, for smart city verticals, in cooperation with our friends from Nokia, from whom you will hear later today, in a panel which is with very high-level representatives of our technology partners, Nokia, Lenovo, iDirect, and Intelsat, who worked with us over the years to develop Datasat in what we are doing today. Based on the experience which we had talking to different customers, understanding different customers, we developed a satellite powered solution for industry verticals. And this is what we are very proud to present today. It's dynamic bandwidth optimization, which is using artificial intelligence to manage data sovereignty, to manage the system of connect, to manage IoT applications, and making cloud services viable across satellite network, independent if you are talking GEO, LEO, or other applications. Another part of development of DataSat when it comes to implementation of teleports, of ground stations, of physical infrastructure, we also are utilizing IoT and artificial intelligence to make infrastructure smart. What do we mean if we say smart infrastructure? It's basically using AI to help us in the design work and to make sure that the design is really done, really implemented by the contractor, that the right components are used, where we're using scene analytics and different type of technologies. Coming to VSAT, I think all of us in the industry have seen upheaval in the satellite industry. There's a lot of myths surrounding the VSAT business. One of them, it's a fixed bandwidth. Some of you may be old enough, like myself, to remember X25, which was basically a nailed-up connection. And sometimes we have the feeling that satellite today is where X25 is compared to internet. There are still customers subscribe to a fixed bandwidth over the month, and you get this bandwidth whether you utilize it or not. Satellite has a reputation that latency is a killer of specific applications. You cannot run an autonomous mining truck with 200, 300 milliseconds latency for IoT applications. Operational costs, maintenance costs are quite high. VSAT is prohibitive. One of our customers, a bank in Pakistan, wanted to digitize and utilize cloud solutions on their network in their branches, but they're still having 18,000 bank branches with DSL. For them, VSAT was not an area they were looking into it. Now we are discussing with them based on dynamic bandwidth optimization, which we are presenting today, and based on our cloud, to establish a cloud 100% based on distributed network over satellite and making satellite affordable for this kind of environments. Generally, VSAT has a reputation as being complex for the operator and for the user. There's a small group of experienced people, many of whom are here with us at this exciting conference, but there's still a shortage of capable people who really understand VSAT and what VSAT can provide for the end user. And last but not least, whenever we talk to customers, cloud, IoT, and high-performance applications and VSAT just don't seem to mix, and it's not considered as suitable for high-performance computing. If you walk around the booth, if you walk around the exhibition, there's exciting developments in the satellite business. One of them is high-throughput satellites. There's the discussion about GEO, MEO, LEO, antenna technology, software-defined satellites, and beamforming are all areas of innovation. But they don't address all the challenges which VSAT poses to the industry and to the users. One of them is CapEx for the operators. It's still a high entry hurdle to become a VSAT operator or a VSAT user. There is one concern which is coming that especially with LEO, there will be less choice for the consumer because the constellation costs are just prohibitive. It takes 4, 5 years, 6 years to deploy the constellations. The first satellites already become obsolete at this time. So there will be less operator, less choice for the end user, which means ultimately higher prices, and you are really locked in. And if you decide to work with one operator today, it's very difficult to change, while if you're in a GEO environment, there is quite a big choice available almost anywhere in the world. Licensing regimes and data sovereignty regimes in each country become more complex, and all the developments in relation to COVID, in relation to the conflict in Eastern Europe, makes licensing regimes and data sovereignty more and more a concern for operators. And last but not least, even with LEO, the cost per megabit is still well above the cost per megabit compared to a mobile operator or a fixed network operator. So this drove us, together with our experience, to develop our solution for dynamic bandwidth optimization. What is dynamic bandwidth optimization? Basically, we are learning by connection through the teleport, whether using datasat frequencies or third-party satellite network. We are analyzing the traffic on each site in the network. You have 1,000 sites in the network based on available satellite capacity, based on environmental conditions on the site on a specific date, based on specific workloads. And the system learns what is the traffic pattern of a specific site, how much site will be required on this, how much traffic will be required on the site on a specific date in the future. Currently, based on our patented algorithm, we have in the oil and gas industry and in another use case for another VSAT operator, we achieve about 97 to 98% reliability of prediction of required bandwidth any point in the future, up to 1 month in the future on a specific site. What are we doing with this data? Based on this data, we manage a system of connect, which means we allocate frequency resources, we allocate bandwidth to a specific site in real time, and we will demonstrate it today later from our team. In real time, we configure the requirements on a specific site when it is required. Not only the satellite frequency, but also coming with it, we use the cloud idea of consumption-based modeling, where we use the licenses for firewalls, firewall throughput, routing throughput, SD-WAN capacity, and allocate it to this specific site as well in the consumption model in real time, which means you suddenly don't have to subscribe to 1 month of 10 megahertz per specific site. We give you the traffic when you need it and how you need it. This works on legacy modems, but it also works on our advanced VSAT modem, which we developed together with our friends from iDirect and Lenovo. This allows us to manage caching and rest backup from site, and it allows us to offer quality of service applications. In one of the discussions with our satellite partners of Intelsat, we are also discussing potential of beamforming for the satellite. Theoretically, there's no limitation why it could not be done. It's more, what's the practical implication? What safeguards are you putting in place? And ultimately, we're also managing self-pointing antennas. Based on the legacy modem, you can keep the existing iDirect modems on each user site. DBO still works well, and you still get the benefit of optimizing the throughput. What does it mean for an operator? What does it mean for a satellite provider? We can become much more efficient in frequency allocation while giving the customer at the same price quality of service and other applications. If we upgrade to the datasat modem, and that's the example what it is, it's a high-performance SE350 from Lenovo with an integrated iDirect IQ200 modem, which will be shipped from the factory already fully pre-configured. What we are talking here is a power of up to 50, 60 virtual machines and cloud computing, high-performance cloud computing capabilities in a high-secure environment. So this allows us, under the dynamic bandwidth optimization, for example, to measure the traffic on the specific site and also request additional capacity from us as a VSAT operator or from any other VSAT operator as required. The traditional modem, you have capacity allocated on site. Using this modem, the modem will detect as well, I have got more traffic on the site than I can handle at the moment. I request additional satellite capacity. Afterwards, if you want to auto-configure based on a commercial model which we offer to our customers, or whether we want the customer via an app to confirm that he wants to buy additional capacity whenever it is available, that's the user interface. Both options are available, but it gives the flexibility. You don't lose traffic on site as a user. The architecture is quite simple. DBO, dynamic bandwidth optimization, runs on the public cloud, on the Datasat public cloud. where all the AI ML applications are running. We took a page from the FreeGPP playbook. What does it mean? We don't read the data. We receive the characteristics of the traffic and manage the traffic characteristics, which means we are 100% data sovereignty compliant, which is a very important point in terms of managing user expectations and being compliant with regulation. That specific data has to stay in a country. I give you one example. If you're in the mining industry in the Middle East, for example, seismic data cannot be transmitted outside the country, or data related to a citizen of Saudi under no circumstances can leave the Kingdom of Saudi Arabia. But if you're a mining company like Vale or BHP, you may want your group communications, your push-to-talk, your push-to-video, or some other critical information about productivity of the mine. You don't want it stored on the public cloud in Saudi, you want it stored on your home server. So we are managing this via our DBO core, which also provides the APIs, first of all, into ServiceNow as IT service management system. So you have a full audit trail, which is payment card industry and security agency compliant, but also interface to ERP systems and our billing system for satellite usage and satellite and the provisioning system. The VSAT modem on site, again, it's either the SE350, so we are replacing existing VSAT modems by the SE350 if we want to have more complex applications on site, if we want to have IoT applications already pre-integrated, and I come to this in the next slide, or we can use the existing IQ200 modems integrated in a flat panel antenna or separated. While we are not limited to iDirect, we are working as well with other satellite providers. We have a strong partnership with iDirect, which allows us to even discuss more detailed integration of the hardware between Lenovo, our hardware partner, iDirect, Intelsat, and Nokia to cover specific adaptations. So to bring it together, what are the advantages of our dynamic bandwidth optimization? First of all, it's a guaranteed quality of service, and that's something which we believe is quite new in the satellite industry, which allows us megabit and on-demand services anytime, anywhere. The user of satellite capacity gets full control over how much he wants to consume and how much money he's willing to spend on satellite services. We have end-user self-provisioning, very important in a scenario. You always have unforeseen things. We are predicting how much traffic we will give, how much satellite frequency will be allocated to a specific site at a specific point in the future. Allows us to be very competitive and make satellite relevant for new industry, like for bank branches, for health and education. But it also allows the user to decide, I have got something unforeseen, I need more traffic now. I want it either automatically configured, so the modem discovers there's more traffic required, give me more frequency now, or at least we can tell him we have frequency available at this point of time in the future, or self-provisioning, I want more data on site because I have a crisis on site, so I want to communicate with headquarters or with a security agency in real time, so I need more requirement today. One of the examples is backup services. We are discussing it with one of our banking customers who is having a couple of hundred ATMs on our network and is now moving towards 4G for ATM services because he requires CCTV. So we are moving him to 4G services, but we are keeping VSAT as a backup by monitoring the ATM traffic and the 4G availability. Whenever 4G on site is not available for his whole pool of ATMs, we give him a fixed bandwidth allocated per month for X hours of high throughput for so many ATMs, so he can transmit CCTV services over the VSAT network almost at 4G prices, because we are just providing a backup by 4G. Again, rather than losing VSAT business to the 4G operators, we are using 4G as a backup. Typical application here would be as well as mobile backhaul or redundancy networks, redundancy solutions, UN applications. If you have unforeseen events like in Tonga, rather than selling fixed capacity on a monthly fee, we can have the peak demand. And peak demand, like in a mobile operator playbook, always is on a per minute basis more expensive, but it gives you the flexibility that you don't burn money all through. It allows us to offer bandwidth patterns. For example, again, one of our oil and gas customers, what we are offering him here now, rather than having a high throughput across the month, which is cost prohibitive, and on the other hand, it affects his business. What we are offering him, that we are giving 10 megabit per second per site guarantee, and X hours per site, we give 50 megabit per second or 100 megabit per second bundles at a fixed price. Another important point for us is really 100% pay-as-you-go services. Anybody of you who has been working on the IoT and cloud applications with end users, yes, we very much respect the hyperscalers, hyperscaling cloud providers, but ultimately, you cannot remove latency from VSAT. You cannot even remove latency from fiber optic networks. We have customers where the application, even 800 kilometers over fiber network, latency is too high. So you have to bring edge cloud to the end user. What better way than to use a high-performance compute node integrated with VSAT, already pre-configured. This is what we are doing with the various industry verticals. Industry 4.0, finance, education, health, and mining are specific verticals, where all the compute applications and IoT applications are already pre-integrated on the server. So when we ship it to the site, it's already pre-integrated. And the user now suddenly, for the price of a VSAT connection, gets a high-performance node. Before, if you're selling an iDirect modem or providing an iDirect modem, at the same, almost for the end user, the same cost, you get a full cloud compute capabilities. What does it do for us as VSAT industry? It makes the VSAT industry suddenly super competitive for IoT applications and for cloud applications on site, because the VSAT team in the end user now can configure and have access to IoT and everything on demand. So you don't have to pay for IoT integration. You already get the mining applications pre-integrated. We can charge, for example, that's what we're discussing with Intelsat. You can have a charging model where you say for one mine, you have 100 sensors, 100 users of group communication, plus application ABC, plus you have as much satellite capacity as you need, because we know exactly what you need, and this has one price per month. So it changes complete the value proposition which we have as VSAT industry. Last but not least, you get a network-wide SD-WAN already pre-integrated. It's part of the basic setup that you can manage all your applications. All end-user sites already have SD-WAN pre-configured, pre-integrated, no incremental costs. And finally, independent on the satellite technology, whether it's GEO, LEO, MEO, Ka-band, Ku-band, the only thing which we are using is the APIs to the teleport configurations and the teleport network management system. So that's what I wanted to present to you today. We really believe this is a technology which can revolutionize satellite industry. It can make satellite relevant for industries which never thought about satellite, like banking sector, like the health sector or education sector. There's a lot of use cases, but I would rather leave the floor to the panel to discuss with you and discuss within each other their views on it. Last but not least, we are in our suite 240. Please feel free to contact any of us just to show you the DataSat team. We will be in suite 240. We will be happy to answer questions here. And we also will be happy to answer questions coming via satellite2022@datasat.com. Okay, thanks. Thanks, Jeff.
Thank you so much, Felix. We'll now move on to the group discussion part of today's opening session. Datasat rejoins us along with special guest speakers from Nokia, Lenovo, and Intelsat to discuss the critical role that satellites play in the global enterprise IoT market and how their new solution enables end users the ability to leverage satellite capacity to its full potential. So we're all very excited to see what Datasat has to reveal, so please join me in welcoming today's panel, Bandwidth as a Service, a new revolution in AI-powered satellite connectivity, led by Datasat's Senior Vice President, Sankar Venkatraman.
Good morning, all of you. That was indeed a very revealing presentation and a lot of interesting subject that Felix was talking about. I'll be the panel moderator. The intent or the expectation from the panel is to dig a little more deeper on the product itself and also get a deeper insight from the various technology providers that have been working alongside with us in the product design and the development. So without taking any further time, I would like to invite the panelists to begin with Felix Thomas Voss, President and CEO of Datasat, Jean-Philippe Gillet, Senior Vice President, Global Sales, Darren Prale, Senior Director, Product Management, ST Engineering iDirect. Charles Furland, VP and General Manager, Edge Computing and Telco from Lenovo. Dr. Munir Zudi, CTO, Nokia Enterprise, Middle East, Africa, India, and China. And Samir Tafish, Head of Innovation, Datasat. So first of all, thanks a lot, gentlemen, for being part of this panel. Felix, it was a wonderful presentation, right? I'm sure a lot of people have a lot of questions, but I have a few questions myself, right? So first and foremost, you have been talking a lot about the data sovereignty. Now, this is a problem that a lot of countries are tackling with, and it's a very elusive problem. Right? How you have addressed the data sovereignty issue in the solution that you have just spoken about?
Okay, thanks, Shankar. So by working with different industry verticals, we really understand what's the challenge. Many people still confuse data sovereignty and data privacy. Everybody knows about GDPR. But if you really go on application level, I'll give you one example, medical data. Medical data of specific citizens is highly confidential, should not leave the country where the data is generated, while specific diagnostic data may be very useful to be shared on a global stage with specific hospitals running up to the WHO and other institutions. So what we are really doing, we are using DBO on site to analyze what type of traffic has which data sovereignty requirements, and via our SD-WAN and DBO, then routing the traffic accordingly into a public cloud in country, or a private cloud in country, or anywhere around the world, which is part of the same SD-WAN network. So any user for a specific customer is part of the same SD-WAN network, so data is 100% encrypted and 100% safe. Perfect. So that's how we are addressing data sovereignty here.
Thanks a lot. Which means it also requires a deeper understanding of the data modeling and a bit of how the application works. So maybe that will also be addressed in the DBO, I would suppose.
Yes. Perfect. So DBO is application aware, and it learns as well from the behavior of a specific site and the specific configuration for specific data. And this is then distributed, again, time and application sensitive to all the other nodes on the DBO, managed by DBO.
Very interesting. Thank you, Felix. Jean, you heard Felix talk a lot about the new trends in the satellite business, right? And we keep hearing about high throughput satellite, beam formation, so on and so forth. Now, because you come from Intelsat and you're one of those leading satellite service providers, what do you think are those big disruptors that we can envisage in the market? And which are those industries you think are going to benefit from these kind of disruptions that we are seeing in the marketplace?
So I think Felix is spot on the way the market is evolving. It's about having more and more intelligence at the edge. So you really want to push the compute at the edge. You want to push the applications at the edge.
Right.
And that's going to generate additional traffic, but that's also going to make the service a lot more user-friendly. I think we have, for many years, lived in the world where satellite was the last resort. When you have no other solutions,
Right.
you use satellite.
Right.
If you do that, the market is shrinking. I think the beauty of what has been developed by Datasat is really to expand the market.
Right.
You create new use cases. Satellite might be backup. You have additional efficiency. You can create additional applications. And this is really where the market is going. And that's where the market is going to expand.
Perfect. And just innovation in satellite alone would not suffice, right? So you have a lot of downstream activities that need to happen just to cope up with all the challenges and all the innovations that are happening in the satellite industry. Question to Dr. Munir. Munir, you are from Nokia, and you have been leading a lot of enterprise digital transformation, right? From your point of view, where do you see the connect of having a disruptive satellite communication solution with the enterprise digital transformation? Do you see a connect between these two?
Yeah, absolutely. I mean, digital transformation has been a big buzzword. You know, it's been on the agenda of so many enterprises for so long, but I wouldn't say it was really their highest priority just because of the investment required and the disruption to the existing operation. But what happened recently is that you see a very good emergence of so many technologies, advancement in AI, ML, and IoTs, and connectivities, and COVID really acted as an accelerator for the transformation. Right. So many enterprises, they had to completely shut down. The ones who have not really invested, who were not really prepared for such an event, who were not prepared for remote operation, remote work, and things like that. So what we see now is that a lot of enterprises are looking into really accelerating that digital agenda, the digital transformation, and they're trying to see what would be really the approach and the strategy behind it. They know their present mode of operation. They kind of have an idea about where they need to be, what should be really their future mode of operation, but how to chart that most optimized path in that transformation is really the trick, right? And how to prioritize it according to the challenges that they have and according to the opportunities that they see in their market, right? So this is the role that we've been kind of playing with them, trying to work with them more on a consultative, engagement, and trying to see how we can position our solutions and the best practices that we see in the industry to help them in the transformation. So what you see usually is that the approach has been based on 3 key pillars. Right. Having a high-performance networking layer, whether it's satellite, whether it's wireless, 4G, 5G, wireline, it doesn't matter. At the end of the day, enterprises don't really care where they get their bits from, right? As long as you have that as a foundation for the transformation, then you have to kind of analyze everything that matters, right? Because collecting data doesn't really make much difference if you don't really have the intelligence really to go through it and guide the decision-making process and optimize the operation. So you need to have that networking layer, you need to have the proper analytics with AI, ML, and then you need to have proper sensing. So you have to digitize everything in there, right? So you have to have a IoT sensing layer in there, cameras, whatever it is, to help that digitalization transformation. So satellite communication undeniably has a role to play there because you see a lot of enterprises operating in remote areas, right? Like mining, like oil and gas. Some of them require also global connectivity, right? Like in logistics and transportations. So this could be a very nice role to play for satellite communications. And at the same time, it can have a complementary effect on existing technologies. So you can still have the entire operation for the enterprise run by a private network, right? And this is something that Nokia has been engaged very heavily with so many enterprises. Now we have, I think, more than 400 private networks deployed. And then the connectivity in the backhauling can be done over satellite communication when other networking mechanisms are not really possible. Obviously, the value that can be unlocked can be huge, so it can more than justify the investment that you make in terms of enhancing the performance, the productivity, the efficiency, and the safety of the operation for these enterprises.
Perfect, but Doctor, I will come back to you on your IoT response that you gave, but hang on to that. But one most important thing, from whatever you have explained, the pivotal point between a digital transformation and satellite connectivity is the NMS, right? Now, without an intelligent NMS, all the feed from satellite cannot be made, the digital transformation will not have any sense if you don't have a very intelligent NMS. So Darren, from your point of view, right, you think the current NMS is going through any disruption, is going through a massive change to kind of accommodate like for what we call as a software-defined services. You think the current NMS is actually evolving itself to become a lot more software-defined service offering?
Absolutely. So, building off of what the previous speakers have said, there is a digital transformation ongoing. And when we look at what we have done traditionally in the satellite network, managing service delivery, managing global bandwidth allocation across these networks, we certainly see applications like what Felix has talked about, dynamic bandwidth allocation, artificial intelligence, being able to allow more rapid consumption of satellite services, tied directly back into the things we're doing from an iDirect perspective to provide services across the existing and new satellite constellations, and really opening up the market to a much broader portfolio or broader range of customers and applications, and adding additional value-added services that will really kind of drive the take rate of satellite services, in addition to terrestrial-based services, and the linkage back into those terrestrial networks so that you can more rapidly provision services, more rapidly provision and deliver those services out to end customers.
Thanks, Darren. Thanks. And one of the magic word that we've been hearing from most of the gentlemen out here is edge compute. At Felix, I heard you talk about, John, you also mentioned, Munir, you also mentioned edge. Now, I think, Charles, you have to enlighten us. What is the difference between a normal edge an edge compute and a normal, like a couple of servers that we have? We see that this is becoming a lot more prevalent in a lot of enterprises trying to adopt what we call as an edge compute. Can you throw a little more light on that, please?
Thank you. Yes, it is different a little bit. Actually, quite different. Because when we talk about digital transformation, when we talk about more intelligence at the edge, bring more of the application at the edge, you actually need the compute capability at the edge. And typically, you would bring a data center server, which is pretty big, pretty loud, also very fragile, need to operate in a certain temperature range and all that. Or you had underpower IoT gateway or workstation that you would bring at the edge. None of those were solutioned at our meeting customer expectations. So edge computing is actually a new category of compute capability that really harvests the same powerful infrastructure you'll have in the data center in a much smaller form factor, as we see here with the Lenovo SE350. It's very compact, so the form factor is important. It's also more ruggedized, so it can operate in all sorts of conditions or non-data center conditions, so operate in a wider temperature range, support a higher level of shock and vibration, dust environment, and so on. Also has more attention to security. As you can imagine, the data in the data center is very well protected. You'll have a guard, you'll have fence, you'll have lockable door and all of this. Now this can be in this on-premise, on a customer office, on a boat, on a factory somewhere. Now, you need to secure the data as much as you would in the data center. So disk encryption, disks are encrypted. We've put motion detector inside, so if somebody tries to steal the device, the data will be locked up and so on. So there's a lot of more mechanism to protect the data, a lot more supporting an environmental that is unfriendly to typical compute power, but still providing the same compute capability to deliver those applications, to deliver this digital transformation, but directly at the edge instead of backhauling everything to a data center all of the time.
Perfect. Thanks, Charles. So I'm coming back to you, Doctor. So you mentioned about how IoT can actually make a significant impact coupled with a satellite connectivity, right? Can you give us some, examples from a Nokia point of view where you have seen the impact of IoT on a business with a satellite connectivity as the prime connection.
Yeah, so I mean, basically, with IoT, it really gives you a complete visualization and control over the operation that you have in the enterprise, right? But at the same time, the IoT has so many diverse requirements, right? So you have to be able to cater for these requirements by having the right solution in there, having the right management for all the IoT sensors in there. So the benefits that you see varies, depends on the enterprise that you are targeting and based on the use cases and the applications that you are providing. So it can be really increased productivity, it can be increased efficiency, it can be improved safety, reducing number of accidents. So one example I can give you, since we're talking about satellite communication, is that like the mining industry. So a lot of the mines are in very, very remote areas. The operation a lot of times is based maybe on Wi-Fi. Wi-Fi is not necessarily the most reliable, connectivity. A lot of times you have some gaps, or you have some kind of drop connections, right? So if an accident happened, or if you have a truck that got stalled, right, for 3 hours, that can cost $250,000, right? So $250,000 really can pay off a complete private networks to cover that site, right? So not to mention really the human impact. Almost not a single year passes by without us hearing about some kind of accidents and unfortunate death in a mine. I think the latest one happened like in October. 50 people died, right? So this is something that has become so common, right? So not only from a pure business operation point of view and the business impact and all the gains that you have, but also from the safety, having a safer environment for the workers in there. IoT, having a better visibility for the operation can really have a huge value unlocked for these enterprises.
Sure, thanks. So Jean, we have heard from this gentleman about the application of the new versions of satellite communications coupled with edge, coupled with IoT. Now, from your experience, which are the businesses you think are going to be really impacted, or I would say benefiting out of these very innovative solutions?
So I think the number of use cases is probably endless. Okay. You look at each of the verticals that we traditionally serve, and there we could do more. So we heard about mining, oil and gas, banking. That's what we do normally. But you could go even further. Healthcare. Healthcare in a lot of countries could rely. If you think about operations of a hospital and you have terrestrial connectivity, the connectivity might not be 99. If you had application and satellite connectivity, you could suddenly have a reliability which is going to be significantly higher. That has value. You can think about agriculture. Mm-hmm. As also examples, agriculture, IoT, this is a lot of things that will be driven, will drive a lot of usage. So I think overall, there are a lot of applications. It's all about using AI, all about using intelligence. That's going to make these usage more and more relevant for our customers.
Sure. Oh, it makes a lot of sense, So Felix, I have to come back to you because we heard from the gentlemen out here. Each one of them have a point of view, right? Jean was talking about how the satellite communication itself is going through a lot of transformation, and we heard about how edge and IoT and the smart intelligent NMS. Now, if I were a customer, and if I were to leverage my existing satellite connectivity and I have to really go through a digital transformation, which means I have to start implementing an edge, do I have to talk to all these gentlemen? Is there a way, how is it going to work? If I were to put together a solution for my own enterprise, do I have to talk to all these gentlemen?
So traditionally, definitely, we would have to talk to each individual enterprise and build the solution. One of the beauty which we think, what all the work which went into DBO in this application is that jointly we developed one application which gives you everything out of one hand. And that's extremely important for any end user, if you really want to understand the application, I think none of us is an expert in all the fields. So I think all of us would admit that. One of the nice things about DataSat, this is why I was stressing on our history, what we were doing, and then we had a lot of discussion also with our friends. I think there's very few companies who have the width and the experience across all the fields like we are doing. So bringing this all together, the satellite guys and the cloud guys and the application guys, even in big operators, our mother company Deutsche Telekom or in AT&T, they are so far from each other, they don't even know they exist. So bringing it together in a company like DataSat or like we are working together now, talking to any of our partners or talking to DataSat, you really get one solution from one hand. And that's something which I believe really distinguishes this kind of approach from even the hyperscalers for an end user, because the hyperscalers, obviously, they understand cloud better than anybody else. But do they understand satellites in detail? Well, they are working on the satellite field. But to really understand, we are really bringing together the best breed technology of the different areas to build industry-specific segments and then fine-tune it. And there's another aspect. We are integrating the end user and the end customer in this experience. So part of the model which we have developed together with our partners is whenever we develop an application, let's say for mining, it comes pre-configured already with mining applications. But if we develop a specific application for one of our customers, we offer to this customer, whether it's a VSAT operator or a healthcare provider or another provider, that we will integrate this specific solution in the general solution and then make it available on the wider network through all our partner networks and through ourselves, and give a revenue share to the end customer. So that's a complete different business model than traditionally. We really believe in a partnership model. So talking to either of us gives access to the whole ecosystem already pre-integrated. So the headache should not be with the end user, the headache should be with us to make the integration work.
So what you're saying, Felix, is I just have to talk to one of the gentlemen out here and I say, look, I need a satellite connection coupled with an intelligent edge and maybe put in an IoT solution. And it's good enough if I talk to just one gentleman out here who will give me the entire solution. Is that my understanding correct? Brilliant, brilliant. So, and Felix, I remember you were talking about in one of the architecture slides, you actually had put in artificial intelligence in the mid box, and you were actually talking about the various features. Now, maybe this is a question to Samir. Samir, you have been the brain behind putting together this solution, right? And we have been talking about how artificial intelligence has actually played a significant role in understanding the user pattern, the consumption pattern, so on and so forth. What kind of algorithm that has gone in, and what exactly you do from an artificial intelligence point of view, which helps the customer literally, pick and choose the bandwidth that they are looking for. More than talking about it, Samir, it would be great if you can actually showcase, demonstrate to us, how we have done it, and if there's a possibility for you to also do some, on-the-fly changes to some of the bandwidth allocation. I think, the audience also will benefit out of it. We from the panel also will really benefit out of it.
Definitely, definitely. I will be showing directly how change, update the on-the-fly, the bandwidths on a live hub directly in Riyadh.
Oh, that's awesome.
Yes, in Riyadh, so I can do the...
So it's all set up for you?
Yes.
Oh, great. So we'll wait to hear.
Thank you.
While Samir is actually setting it up, Charles, quick question to you.
I can have the screen.
Quick question to you. So I see that it's a Lenovo box, and you have put in the iDirect modem inside the Lenovo box. Now, these boxes will actually be deployed in an environment which could be very hostile, right? It could be cold, extreme heat, so on and so forth. Now, how difficult is it to maintain these boxes? Because it's not going to be possible to send a technician, right? And because we are talking about almost having, it's a hyper-converged infrastructure, have so many vital, very important applications hosted in them. How easy or difficult is it, maybe what we call as a SZTP, zero-touch provisioning?
It's a great question because it's often an underestimate challenge where we have most of the administrative tool set to manage thousands of servers in the data center. Now you have a few servers in thousands of locations. So as much engineering and innovation we've put in our hardware itself, probably as much, if not more, went into the administrative tool environment. So in the lab, it always works. People are super happy. They demo it, and wow. Now we say, we need to deploy this in 70 locations a week for the next 2 years. Okay, all over the world. Then it becomes a challenge. So we've developed a series of tools called Lenovo Open Cloud Automation that basically minimize the IT requirements. So you can ship the device to the destination, turn it on, and it will automatically recognize and be part of the inventory, manage the low level, of the firmware, of the hardware itself. You can restart, you can take remote control of the server from anywhere in the world as if you were physically connected in front of that server. And that could be on a cruise ship somewhere in the middle of the ocean. So as much effort went into automating the remote management because we truly understand that this is hundreds and thousands of locations, hours or days away from the closest IT technician. And we need to have that complete story to be all successful here. Otherwise, it becomes a management nightmare.
And where do you think these edge compute has played a significant role? Which are the industries you think has benefited most out of these edge?
We talked a lot about healthcare and many of the industries, but some of the use cases that I recall, as I was talking to fishermen in the Gulf of Mexico who have those edge servers directly on the boat. And I'm like, why do you need an edge AI in that environment? And obviously, as they empty the net on the boat, cameras are monitoring the environment, the fish. This compute power on the server is measuring each fish and detecting if they are too small to be legally fish, right? And if they're too small, it gives a warning and they throw them back into the water. Versus going into port, getting security, getting an audit, and then getting a fine. So having the compute capability to develop and find the insight in the middle of the Gulf of Mexico as you're fishing, know what to do with the information that has been generated, upload only the relevant information to your cloud environment. You don't want to, and find the insight directly at the edge is one of the use cases that is, I guess my point is you can find edge computing pretty much everywhere, even on boats in the middle of the Gulf of Mexico.
And it also couples very well with the satellite communication, right? Of course, you're not going to get any other communication other than a satellite communication in a boat.
Absolutely.
Right? So it's a perfect case study. So Samir, does it work?
Yes, we are ready.
Please go ahead.
Okay. The screen, I believe. It's not shown yet, my screen. Yes.
There you go.
Thank you. Okay. Here we are representing now the reading from the iDirect Hub, the NMS directly. And I'm going to configure one of the terminals, which is my terminal in my office over there. I'll be updating the bandwidths, whatsoever bandwidths you can request. Let me put 512 up and 512 kilobyte down. And just by like 2-3 seconds.
So Samir, just to make sure that we all understand, so you are actually configuring a live terminal in the Kingdom of Saudi Arabia.
Exactly.
Which was working in a predefined bandwidth. Now we are able to change the bandwidth.
Definitely.
Remotely. Is my understanding correct?
Yes. It's the engine of the AI. After predicting the bandwidths of the AI, what should be the terminal using and anything,
right?
Okay, it will give the order to this application to change the bandwidths up or down okay, and depending on the utilization of the bandwidth. Now, as we saw, it took about 5 seconds to update the bandwidths directly on the NMS, on the modem, on the site as well.
So Samir, this is very interesting to see, but at the same time, it gives me a little bit of a scare. How secure is this application? Because if somebody, who is not supposed to actually alter the parameters, they start actually tinkering with this, then your entire connectivity goes for a toss. So how secure is this application?
This is normally, it's hosted on the cloud, okay? And it's managing the NMS on a secure network, on a private and secure network. So it is not accessible from outside at all. And it doesn't, and even when studying and reading and everything, we are not accessing the utilized data of the customer.
Right.
So data sovereignty is totally secured and everything. We're not reading anything, just the logs from the NMS, updating on the NMS, and reading back from the NMS only.
So Darren, what is your point of view, Darren? You've seen this, where we are able to change literally the parameters of a particular customer on the fly.
I think it's a huge enabler, candidly. Having the access to bandwidth is step one. The ability to overlay value-added applications on top of that bandwidth is step number two. But then to be able to dynamically allocate that bandwidth so that the end user is only consuming as much as they need when they need it is a huge enabler and really drives down the end user's cost, while still allowing the network operator to allocate bandwidth more dynamically across their footprint. So before, very strict, very kind of rigid rules about who gets what bandwidth and when, more of a cumbersome process for reallocation of that bandwidth, really was a limiting factor in some of these applications that maybe only needed bandwidth occasionally, maybe only needed real-time connectivity occasionally. We talked about some of those applications, but with the ability to either on demand, as you've shown, or through artificial intelligence and mechanization to be able to dynamically change that is a huge change in the way end users are going to consume satellite services. I think it's a game changer.
Thanks, Darren. Thank you. Samir, another question. Now, you were talking about artificial intelligence to predict the consumption behavior. Now, how accurate can you be in terms of predicting a consumer's behavior over a period of time in the future?
Okay. On the NMS, we have a history, for example, for 6 months normally. This is okay. Based on this 6 months, we reached an accuracy of 96 to 97% accuracy on the prediction for future time, like 1 week, 2 weeks, we can predict based on hourly basis as well.
Very interesting. So what you're saying is you have understood the past consumption behavior based on which you are able to predict what the customer potentially can use in the future.
Exactly, and we continue learning as well.
And let the customer know if there is going to be any additional bandwidth that they can reallocate. Mm-hmm. Very interesting, Samir. Yes, very interesting. Thank you very much.
Thank you. Thanks.
So Felix, now that you have the solution up and running, right? The most important question is on the commercial model, right? In a traditional way, a satellite communication or a satellite subscription is done on a fixed contract. Now, how do you see, with all this dynamic bandwidth coming into the play, how do you see the commercial model being redefined?
So we really see it moving towards almost like a mobile operator type of consumption-based model, moving from megahertz to megabit per second consumption with peak, on-peak, specific bundles. That's one part how we see the model to change from the end customer. So it's a quality of service-based and throughput-based pricing rather than a megahertz-based pricing. So let us worry about the megahertz. You know your business needs, and how much money you want to spend for your specific business needs. We give you the capacity when required, how required. The purpose is not to drive the overall consumption down, but to make better use of available resources. Satellite capacity is a scarce resource. That's number one. Number two, on the use cases, we see a complete different paradigm. You had the question before, how many people do I need to talk to for a solution? Which also means from how many different people do I buy? I buy the firewall from Juniper, I buy IoT from Nokia, hardware from Lenovo, satellite from Intelsat, the modem from iDirect, application from Datasat or Microsoft or whomever. But now we have the opportunity to bundle it together based on a use case. So VSAT is not a connectivity anymore, but via DPO, we are basically saying we have one specific mining use case and there is a fixed price for it. I don't need to bother to how much capacity do I need, what is the best IoT platform, what's the IoT application. I just need to define what's the applications I want to run, and I can get all bundled in a single price without having to deal with all the individual components. So that's a complete shift from us in the satellite industry selling megahertz or megabit per second to selling a complete solution. That's a setup for a, I don't know, small mine, small university with up to 1,000 students. That's the setup. Let us deal with what capacity is required, what application is running. Let the digital transformation really enable the end user to provide its core business. The core business is not to coordinate between the 5 of us or 6 of us.
Brilliant. Thank you very much. Thank you very much, Felix. I think we're almost on top of the hour. I would like to take this opportunity to thank each one of you gentlemen to having taken your precious time to be part of the panel and to also discuss about the solution. Thank you very much.
Thank you. Thank you.